We'll be talking about Docker as a containerization tool. So first, let's learn what is containerization, why do we need Docker, what is this and all. I'm sharing a blank screen. Yeah. So let's talk about Docker. What is Docker? You might have heard this a lot, right? Till now, whatever topics we have learned, like Git, Jenkins, whatever topics we have learned, yeah, they might be used in Agile methodology also. Like testers also might have used it. Jenkins, they might have used it to automate the test execution and all. But the complete approach of DevOps, or else the way of deployment and the way of development have got revolutionized with this Docker. So this Docker makes a lot of sense, and this is the one which makes DevOps more efficient and effective today. Today we are seeing DevOps at this stage. I can say Docker has a great hand in it. All right. So let's understand this. Docker is again very simple, very easy. Only thing is, again, you need to understand it properly. Learn it thoroughly in a structured way. Understand it properly. If you learn the basics, Docker will be very simple. So first, let us understand what is this. Why do we need it? To understand this, let me give you a simple example. Let's suppose there is an application. Okay, let you consider it whatever be the application you need. You let's say some social network application, some charting application, some banking application or gaming application, whatever it is. Okay, let's consider some application, and this is developed by some company called A, right? And yeah, there were so many clients, so many users ready to buy this application, like client one, client two. So many are interested to buy this and use this application. So yeah, whoever are interested, this company want to provide their application to them. But this application has got some prerequisites, like it works only on Ubuntu 16. It should have Tomcat 9. Those are the prerequisites, right? And it should have Java 8. These are the prerequisites for this application, right? Okay, then client one bought the application, but he has got Windows operating system. He doesn't have this Ubuntu 16. And also this client two has got Linux, but he's have got CentOS distribution of Linux, right? And there is one more client, client three. He has got this Ubuntu 16, Tomcat 9, Java 8, and so on, right? He has got all the application requirement. So how can we provide this application to these clients? Providing the application to this client 3 is very simple, isn't it? But how to provide the application to this client 1 and 2? How can we handle them? See, we should be able to provide the app to all the users who are interested, right? It's not that we'll provide the application only who has got the prerequisites. Also, it's not that everyone will have this prerequisites. Let's say this client one is having Windows environment. It's not that just because of this app they can't change their environment, right? Or else maybe they don't know how to do it, or else they may not be interested to it. But how to provide this application to this client one and client two? How to handle them without losing them? How can we provide them with the app? Any solutions to this problem statement? What is the solution, do you think?
Like one
Or
can
we'll have
virtual machine, like installing what, like the way we have done it earlier as well.
There are multiple solutions to this problem statement, right? One solution is having virtual machines, right?
correct.
Like in the beginning, initially in Linux classes, we have learned what is a virtual machine. Virtual machine sits on the host operating system. It will have its own operating system, works like a separate machine. So what we can do, let's say this client is having Windows environment. On this, we can create some Ubuntu VM, right? Like Ubuntu 16, put Tomcat, Java, whatever this application is, and provide this VM to the client. So he can run this application on the VM. So this is one solution. One of the solutions we have managing a VM, right? So share this VM to all the clients, the problem can be solved. This is one solution. The other solution is containers. Containers also does the same. Like you can create a container with this Ubuntu 16, which have Tomcat, Java application, share the container to the client, they can use it. Both solves the problem here, right? Both does almost the same, right? You can use either of these scenarios. Then what is the difference between them? If containers are doing what the VM does, what is the difference between them? Isn't it? Let's try to understand them. Let's try to understand this. Let's say we are having VMs and containers, right? So both solves the problem of containerizing our application. Like here you will create Ubuntu 16, put the Tomcat, put Java and all. Same is the case with container. You containerize all the, like you can have a container of Ubuntu where you have Tomcat and all and share the container. Both does the same. Then what is the difference? See, both uses the concept of virtualization. Both uses the same concept, right? But in VMs, virtualization is done at the hardware level. Means we can say virtualization is done to the hardware in VMs, whereas virtualization is done to the OS level in containers. Right? What is meant by this? Let me give you a simple example. To work with the VMs, let's say I have a laptop. I want to launch a VM. I want to start some VMs. Then you should definitely have, like your hardware should support this. Means like you might have noticed it. If you go to BIOS, there will be an option called Enable Virtualization Technology. This option should be enabled to launch the VMs. Means the point here is to launch the VMs or to work with the VMs, we need to have virtualization enabled. We need to have virtualization here, right? Means your basically your hardware should support this. Then only you can have VMs. But in the case of containers, you don't need this option. Means you don't need any support from the hardware to launch or to manage this multiple to manage your application in the container. Means here, virtualization is happening at the OS level. What is meant by this virtualization at the OS level? We'll understand in few minutes with the architecture. Just understand, yes, virtualization is done at the OS level in containers, and this is called containerization, right? Virtualization happening at the OS level is called containerization. Means you may be having a question, is containerization replacing virtualization? Never, it's not. What is it doing? It's a next step to virtualization. This is next step to virtualization. So virtualization will be still there. VMs will be still there. Above that, you will pack your application and the dependencies in the form of a container. That's called containerization. This is the next step to virtualization. So it's not going to replace virtualization, right? So this is containerizing your app. Suppose you want to containerize your application. Like how do we do that? That's where Docker comes in. Means Docker is a tool or a software, right? You may consider it a tool or a software, whatever you call it. It is a tool which will provide you this containerization platform, which will help you containerize your applications, right? There were many tools which can help you containerization, like Docker, um, Rocket, Creo. These are all different containerization tools, but out of it, Docker is very famous and very widely used, right? So, meaning, let's say you want to run some Python application, you need to have Python installed, right? Same is the case here. If you want to create a container, or if you want to run a container or launch a container, modify a container, whatever, if you want to work with containers, you should have Docker installed and running, right? You have to install Docker, then you can create some container. You can containerize your application. Got this point, all of you? Any questions? So, to understand this in detail, what is meant by virtualization to hardware, virtualization to the OS and all, to understand this differences, let's talk about the architecture of VMs and containers. If you understand the architecture of VMs and containers, you can understand this concept, like what is meant by virtualization done to the hardware, what is meant by containerization. So let's proceed. All right. So what is Docker? Docker is a tool which provides containerization platform and helps in running containers. It helps developers to pack the code along with the dependencies and ship it as a package. It ensures our application works seamlessly in any environment. We'll talk about this in a while. Yeah. Let's talk about the differences now. See, this is the first one is the architecture of virtual machine. Let's understand this in more detail today. Hmm. So see here, this is the infrastructure. Okay, maybe your laptop or physical servers, whatever it is. Above that, you have got some host operating system and then the hypervisor. What is a hypervisor? Even this one we have learned, discussed in the previous classes. What is a hypervisor? Can anyone recollect?
And a
That
virtualization software.
Yeah, hypervisor is
The
a
platform basically on
software.
yeah.
Yeah. So this is a software which help you create your virtual machines, launch your virtual machines, which will help you allocate resources to your virtual machines and so on. Right? That's a hypervisor like Oracle VirtualBox, VMware, VM Workstation, and so on. So that's your hypervisor. Now above this, you can have a virtual machine, right? So this is your virtual machine one, right? This is second virtual machine, third one. So we have got three VMs. If you again notice here clearly, every VM is having its own operating system, which is called as the guest operating system. About that, your application, this is the application we were talking about, the gaming app or whatever it is, and the binaries and libraries means binaries and libraries of the dependencies for this app. Like let's say you need Java, you need Tomcat for deploying this app 3. So those are all the you have all the boundaries and libraries of those dependencies. That is your virtual machine. And here, even like it works like a independent machine because it has got its own operating system. This operating system is not dependent on this operating system of the host. This is host operating system, right? But the resources required for this VM will be provided by this host only. Means let's say this VM consumes 30 GB, right? So we'll allocate the GB from the host only. And out of this 30 GB, majority of the resources will be consumed by this guest OS itself. Like maybe 15 GB for this OS, and then the rest of the 15 GB for this app and the dependencies. Same is the case here. Let's say this VM is consuming 20 GB. Out of it, certain majority of the resources for this OS, and then the app and the dependencies, right? Also, how many VMs you launch on your host depends on the resources available on your host, right? If I put 10 VMs, it may not work, right? It purely depends on the resource available. Here I have only, let's say, 50 GB. Okay, out of it, 30 and 20, I cannot assign to the two VMs, right? I need some resources for this host itself. So I can't assign two VMs which are of size 30 GB, 20 GB. I can't launch the third one. Maybe I may have some 80 GB. Then yeah, this is possible. 50 GB here. Maybe this is some 10 GB, 60, 20 GB left for the host. So it all depends. How many VMs depends on the resources available on the host, right? So you should not put too many VMs, because if you put too many VMs, it may just degrade the performance of your system. The system may be hanged up. So many consequences you have to face. So even these we have discussed in the beginning. So resources will be consumed by the host only. So we should choose the VMs like which consume minimum resources from the host so that you can have a better performance. So every VM is having its own operating system, and then the application and the libraries. And if you see here, every VM, because it's having its own operating system, this is going to be really huge and heavy, right? VMs are huge Because see, they just work like a normal another machine. That's all. It works like another independent machine. So obviously, VMs are very huge. They are huge. They consume a lot of resources. They also run slowly, right? They work slowly. Like if you if you keep on increasing the VMs, definitely they work really slow. So this is the architecture of virtual machines. Right here, let me ask you. Okay, let's say this is my host. Let's say my host is Windows 11. Can I have a VM of Ubuntu distribution of Linux? Can I have CentOS distribution? Can I have Windows, some other version? Whatever, like older version of Windows, whatever, some other version. Were all these VMs are possible or not?
Yes, possible.
Possible because say every VM is having its own operating system. The operating system of the virtual machine is not dependent on this host OS. So this is very much helpful in our scenario which we are discussing. Like client needs a Linux environment, so we can create some VM, put the dependencies there, app also there, and share this VM. They can just use the application from this VM, which is very cool. Right. Similarly, for our learning purpose also, like we want to learn DevOps, right? DevOps means Linux environment. Let's say a majority of us are having Windows or else Mac. So what did we do? We can spin up a VM, right? The same thing we were doing, but of course a VM from AWS, right? So this is the architecture of VMs. And here you have to remember, make a note here, like for to launch this VMs, yes, you have to enable virtualization technology in the BIOS, right? I don't know how many of you have faced it. By default, it will be enabled only. But in case if you want to do any changes or somehow it has got disabled, you have to go to your virtualization in the BIOS and enable this option. Means basically your hardware should support this kind of virtualization, right? So this is about virtual machines. Now let's talk about the architecture of containers. So this is again the infrastructure, maybe a laptop, like let's say some version of my laptop. Sorry, this is the hardware. And then, yeah, my laptop with the operating system Windows 11, right? So now I want to run containers. Yes, you can install Docker there. See, Docker is native or else developed for Linux. Basically, initially it was developed for Linux. But now we have Docker for Windows also. From Windows 10 and above, you can run Docker natively, right? So yes, let's suppose I'll install Docker here, which is called Docker engine or Docker daemon, whatever you call it. And you have to start this Docker engine. Then you can start your containers here. You can launch your containers. This is a container one, second container, third container. What is container? What is a container having? It's having the application and the dependencies. That's it. Nothing more, nothing else. Right? Means you can imagine container. What is the dictionary meaning of container? Container means a holder, right? Basically a holder which will hold like whatever you need. Let's say a container which will hold here my application and the application dependencies. That's all. Nothing else. Nothing more. What is meant by nothing else? See here, if you compare this VM with a container, what is missing?
Get to it.
Right? So, meaning containers will not have its own operating system. They'll not have their own operating system. Then you may be having a question. Then how come you say this is Ubuntu container, this is CentOS container, right? So how come you say that? Yeah, it's because see, it doesn't have its own operating system means it will not have full-fledged operating system. It will have only the binaries and libraries of the operating system. Or else let me tell you, it will have only the minimal operating system, right? Only the minimal operating system, not a full-fledged operating system. Because see, we don't need a full-fledged operating system always. We don't use all the utilities there. Whatever utilities needed for the application, they will be present. Hence you may call it as Windows container, I mean sorry, Ubuntu container, CentOS container, or Windows and so on, right? So that's a major point. And what is the advantage of it? See, if you notice, the operating system itself consume lot of resources, right? Here also resources will be shared from the host only. Here also they will consume, even they consume the resources, they'll be shared from the host system only, right? But because it doesn't have the operating system, they don't have their own operating system, they are light, which means they consume less resources, right? Only the resources for the small pack, it's like a package, right? You don't need to provide the resources for the VMs. Means lot of resources were saved, so much of resources were reserved so that you can launch something else or you can launch some more containers there. So they consume very less resources, but still they work like a normal machine. They can start, they can reboot, everything you can do like a normal machine because they will consume the operating system of the host. Okay, they will consume the operating system of the host. Right? Let's say here I'm saying it's a Windows 11. They'll share the operating system of this host only, means Windows 11, means they'll share the kernel of the host. They'll not have their own kernel. Right? So this is the difference. Because they don't have their own VM and they consume less resources, they're obviously very light and work really faster. Right? And when you have limited resources, when you have limitation on the resources, or else when you want to deploy your application very quickly, this is the best approach. You just pack your application and then the containers can be created very quickly on the fly. Even they can be destroyed very quickly. Also, another major difference is for VMs, whenever you create a VM, you have to launch some resources to it. Here, you don't need to allocate the resources beforehand. Containers will consume the resources on the fly, means they will you utilize the resources on the fly dynamically. You don't need to assign them prior the task. Like before running, you don't need to assign the resources. They'll consume the resources dynamically. But of course, yeah, you can even control how much resources they use. You can set the limits and all. But you don't need to allocate them beforehand. Right? And yeah, see here what is happening. Virtualization is happening at the OS level. The containers were sharing the host OS. This is called virtualization happening at the OS level, which is called containerization. So I want to implement this to my application, means I need to install Docker. Here everyone got the differences, all of you?
Like I have one doubt. I'm not clear. If they don't have get wet, then how will the application run?
They'll have the minimal OS. They will not have the full-fledged operating system. They'll have the minimal operating system, like only the binaries and libraries which are required. Not a full-fledged operating system, but the minimal operating system with which they can run. That's why, see, they are not having their own kernel. They are sharing the kernel of the host. They'll utilize this operating system, host operating system, on which they are running. Here, host means, one second, please. Here, host means the system on which your containers are running. So the operating system of the server where these containers are running. Tell me. Some of you are asking a question.
Yeah, Preeti, what you mean while application running in a container, this environment will share a single OS, right? You mean to say?
Correct. Correct. That's what I'm going to ask. See, your let's say my laptop is Windows 11. I have installed Docker here. Can I run a Ubuntu container or CentOS container, or can I run Windows container, some other version? Which of them are possible?
All of them
Yes.
are possible.
All of them are possible. Linux container, can it share the kernel of Windows? Like I was saying, it will share the kernel of the host.
No, but since you
So
said that
this
we
is
will
not
containerize the binaries.
See, containers will not have their own operating system. They'll share the kernel of the host only. right? They'll utilize the operating system of the host. Let's say they'll have just the binaries or there's a minimal operating system, right? So basically, they'll not have their own kernel. They'll share the kernel of the host itself. So if that is the case, if the host is Windows, you cannot run Linux containers because a Linux container cannot share the kernel of Windows.
Yeah,
Only
basically
this
Unix
is
will not go with Windows, only Windows will go with Windows.
that's
Whereas
what
irrespective of any flavors in Unix, will if it is Unix, then it will be compatible.
so your containers operating system should match the operating system of your host. If I'm having Windows laptop on that, I'm going to install Docker and run containers. I can run only Windows containers, right? This is the point you need to make a note of. Let's suppose this is my Windows. Okay, this is my laptop, which is Windows. I will install Docker here. Okay. So on this Windows, which containers I can run? I can run only Windows containers. Any version is fine, but the base operating system should be Windows. I can launch only Windows containers here. Correct? Yes? Any confusions here? Only Windows containers. But what if I want to run some Linux containers here? You cannot do on this directly. What you can do is you can launch a VM here. On my Windows, I can launch a Linux VM. Then install Docker on this VM. Okay. Then on this VM, I can have Linux containers now. Any distribution of Linux is fine. It could be Ubuntu or CentOS, whatever it is. Because this becomes the host for them. They will share the kernel of this host. Right? This containers, Linux containers will share this kernel. This Windows containers will share this kernel because for Windows containers, this is the host. For Linux containers, this Linux VM, which is running on Windows, is the host. Got the concept, all of you? Yeah?
But Preeti, one question actually. Cannot we have instead of using it on a laptop, cannot we have a Windows VM and then
Whatever
just
it
to avoid
is.
the usage of the resources?
Just as an example, I'm saying you can directly have a Linux VM on AWS. You can launch Linux containers, or else if you want, you do it on Windows, whatever it is. Right? See, if you notice here, again VMs were used, right? Where are your containers running? Your containers are still running in a VM, right? So this is how the containers work. So like I told you, the advantages, they consume less resources, they can be deployed very faster, right? You can create them on the fly. These are all the advantages of containers, right? Not only this, let me tell you how development approach and deployment approach change with Docker. Can I go ahead? Is the architecture clear for everyone? Good to go?
Yes, Preeti.
Right. So let me tell you here. Let's talk about development before Docker. Development before Docker means, let's say, they need to start deployment. Sorry, they need to start development, right? There might be different developers. Let's say there were 5 developers in a team. Each developer may be having their own operating system, right? Or else, let's say they have different environments. Some developers have got Linux, right? Some of them have got Windows. Right now, they have to develop this application and they will do unit testing, right? They have to just test the application for themselves. They want to run the application here. Even they want to run the application here. So let's say let's say we were, when we talk about application, let's say it's a var file. Okay, because we already have discussed about var. Now to run this var file, the challenges you are facing right now to create CI/CD pipeline. What are the challenges? You are installing Java here, right? You are struggling whether it is Java 8 or Java 11. Am I correct? You are facing this issue already, right? So you are working on whether it is Java 8 or Java 11. You are installing Java on every machine. Let's say on Jenkins Master you are installing. On Jenkins slave also, you are installing. This suits the use case for deployment. I'll talk about development also. Development also same, right? You are searching for which Java version is compatible. You have to talk to developers. You have to get to the right version and you are installing. In Windows also same, right? In Windows also, you may have to install some version of Java. The way of installation may be different. Installation steps may be different here, correct? Also same is the case. You have to install maybe Tomcat here to deploy it, correct? Isn't it? Here also you have to install Tomcat to deploy this WAR file. Of course, we were doing it through via Maven, and also you have to take care of all these steps. We did not deploy it. For build process itself, we were struggling with these dependencies. Correct? Tomorrow another slave came up. Jenkins slave 2. Again, developers, we need to talk to the developers. Let's say the slave 2 is Ubuntu. We have to check which version of Java I need to put in Ubuntu, or else which version of Ubuntu we should have as a Jenkins slave 2, correct? Sometimes developers will participate in the build process, so they should know which version should be installed. So finally, they should check the compatible version and install it all through, correct? So which is going to take a lot of time to prepare the build servers. Developers have to prepare build servers or else their own machine to test the application. So they have to install all these dependencies on every system, correct? Which is challenging. Also, these systems may be of different OS. They may be Windows systems, Linux servers, again, different distribution of Linux. They have to check for the right version and they have to do it, which is just really challenging, correct? So let's suppose, okay, they have identified the servers, identified the version, they have installed the application. But let's say some updates happened and suddenly this Java 11 got upgraded to latest version of Java, Java 17. Again, application will fail, correct? They have to set again these versions. They have to put the right versions. They have to put them back, which is going to be a great challenge, right? What developers are facing. Similarly, the case with the deployment, this is how development process, there were challenges in the development process. Similarly, deployment process also. See, like we were saying, we were just packaging the application. This is about all the development, build, compile, packaging, all this comes under development process mostly. So yeah, this is having a lot of chance. Same is the case with deployment. Now I want to deploy this WAR file on Linux or else Windows, right? We have to check again the right versions of Tomcat because that has to be running on a Tomcat. We have to install right version of Tomcat. Maybe Tomcat 9 may not be compatible. You have to put Tomcat 8 on all Linux and Windows and you have to do this, right? Let's suppose, okay, fine. I have installed Tomcat 8 everywhere. It was running. There might be some upgrades or else Tomcat might have been deleted or uninstalled. What may happen? Your deployment fails, right? You might have faced this in real practice also. Like sometimes what happens, application works in dev environment, test environment, but may not be in prod, right? So if this is the issue, like you'll be having nightmares, right? You have to sit all the day, right? Or throughout the night, fix this issue. First, identify the issue, fix the issue, which is going to be great challenge for the teams. Have you ever faced this? And the major, like the main reason for this would be the compatibility issues, right? The application dependencies might be missing. Am I correct? So these are all the challenges development and deployment process have got, right? To handle this, here what are we doing? We are means in DevOps approach, they will not share this WAR file directly to ops teams, or else they will not deploy this directly. Rather, what they'll do, they will pack this WAR file along with the Tomcat, along with the dependencies it needs, like the right version of dependencies. They'll pack the application along with the dependencies, and this pack of the application along with the dependencies is called the container, right? This is your container. And what they're going to do, they were going to share the same container throughout all the environments, maybe dev environment, test environment, prod, whatever be the environment, they'll share the same container. So irrespective of the environment, the same application with the dependencies is coming up, right? So there is no possibility of searching for dependencies and installing the dependencies in every environment manually, separately. There no need to do that way because application is coming along with the dependencies. As a DevOps person, I am least bothered about those dependencies. right? I just run this container on test, dev, prod, wherever I need, right? So deployment process becomes faster. Also, there were no hiccups. Also, if the application is working for in dev and test means it would work on prod also, no environmental issues, right? So application means what we can say, application works seamlessly in any environment. Only the environment configurations may differ, like you may have huge servers or number of servers in prod may increase, but the environments would be similar, right? So the application works seamlessly in any environment. That's how this containers, Docker, have revolutionized the way of development and deployment process. Means to summarize it, see, it's not that earlier before DevOps, if they used to have a virtual machine. On this virtual machine or a server, whatever you consider it, okay, they will install all the dependencies my application is. Then they will put that application. But now that's not the case. They are not going to each server install them manually. Your application is coming with the dependencies, which is in the form of a container. You run this container on dev servers, test servers, prod servers. Got it clear? So there's no point of incompatibility in the dependencies. Same dependencies. So that's how Docker revolutionized this process. And this led to the DevOps approach, which we are implementing right now. Hope this is all clear now. Yeah.
Preeti, it is whose responsibility to containerize it, everything under one bundle?
Yeah, actually developers, when they create a WAR file, right, it's a developer's responsibility to create a WAR file. If it has to be included in the pipeline, they'll give you the goals, Maven goals or build automation tools, scripts and all. So they will create the WAR file. They will also create a container. Okay, how to do that, I'll show you. They'll also create the container. But in smaller companies, maybe in startups, DevOps teams may be asked to do that. So everyone should know how to containerize that. To containerize this app means to put the application along with the dependencies, you don't need to be a developer. Okay, anyone can do. In some companies, the scenario would be like developers. Let's say developers doesn't have any knowledge on this. DevOps team have to containerize it. But in some teams, in smaller companies, even developers may be doing it. It all depends on the resource availability, their knowledge base and all.
Exactly.
So everyone should know this. Even testers should know this, because even they will set up their environments. Testers should have also idea on it. So like that's what I'm saying. You are a developer. You still want to continue as a developer because you love development. Not that everyone is moving to DevOps, but still you need to know this. You need to know containerization. How do you containerize your app? So that's why these topics everyone should know, even though you are not being a DevOps person, if you are working in that DevOps methodology. Right.
Preeti, I had one question. If the container is created using a Windows system, it will not work on the Linux.
It will not work. If it is a Windows-based container, it will not work in Linux.
Okay. So means if one developer has a Linux operating system, he will have to install
another container, but same container across all Linux, same container across all Windows. Also, if you create a Linux container, you can easily convert into the Windows version. I'll also show you that in some session.
Okay, means in a case like few people have Linux and few people have Windows, you will have to create two containers, right?
Correct.
Okay.
Correct. Right. So here, some differences with respect to the work scope. If you want to run multiple applications, use VM. Multiple applications in the sense, okay, let's say I want to have a gaming application. Maybe this project also supports another application, like let's say a weather application, right? So you have different applications, right? So if you want to run multiple applications, use a VM. Means on the same VM, one second. If you want to run, okay, you want to run multiple applications like a weather application and the gaming application. You can use a VM because on a VM you can put multiple applications because it's very huge. See, if you want to run multiple copies of the same app, means see on that VM, I want to run 100 containers of this weather application, right? Or else a gaming application, then you prefer containers. See, the basic thumb rule is one application per container is the best practice. One app or one service per container. I'm talking about applications like gaming app, weather application. You may also have services like you may have Tomcat container. You may have a just container which will give you some service, right? Like a web server may be there in your container. So always the best practice is one application or one service per container. You can put multiple also, but this is the best practice. So I have a weather application. I'll put them on a container, right? You want to scale them. You want to have 100 weather applications. Use containers. Let's say I have two applications. I want to run them parallelly. You can host them directly on a VM, right? And portability. Working with VMs are platform independent. Like we discussed, you don't need to bother about the host operating system. But containers are platform dependent. And VMs consume a lot of resources. When you have limited resources, when you are short of resources, you have constraint on the resources, better you go for containers. Containers are lightweight, they're just like a package. So go for containers. And for VMs, you don't need to have root user privileges, but to run containers, you need to have root user privileges. Right? These are few differences between virtual machines and containers. But these are not going to be a drawback of containers because you spin up a container of that particular operating system, like which is compatible to the operating system, and launch it. So when you compare with the advantages it was posing, this is not going to be a challenge. Like I told you, the process of deployment completely changed. You are not going to install the dependencies manually. If you are doing it, of course, you can automate it on a VM to install these packages. You can automate that process. But here the point is, later on, what if they are updating? Or else initially in the beginning, you want to deploy the application faster, you have to search for the dependencies, fix those dependencies manually. But all those challenges, drawbacks were being eliminated here, right? You will learn it, okay? Just wait for few minutes. You are going to learn all of that. So you'll get more clarity. See how development changed with Docker? Build once, run anywhere. Means you just build a Linux container once. You run it anywhere, right? They are bothered about building the containers with the code, libraries, application, data, and dependencies. That's all, right? So developers will be bothered about their application code and their application report. They need not worry about it's not working in production, like what may be the issue. Like they need not work on or support production, I mean support ops teams for it, because that issue is no more there. So how deployment change? Configure once, run anywhere. They'll start a container on a prod. They can scale up, they can maintain, manage them, that's all, right? They can run the same container on any other environments. They are bothered about running the containers, that's all, right? No more compatibility issues. They have to just scale them. They have to just see that end users can access the application, that's all. So yeah, this is the environmental issue I'm talking about some time back. See, code is working in developer's machine, but not in other environments. See, there is some problem with the code. An application works in developer's laptop but not in test or prod due to difference in computing environments. Right? This problem arises when developers are upgrading their software version while ops may be using the same version. That could be the scenario, or else the versions may be upgraded automatically during the system upgrades and all. Right? Whatever be the reason. So how do we handle it? Through container. You create a container, run the same container across all the environments. Let's suppose developers have upgraded their version. They can again create a new container, share that container with the teams, other teams. So environmental issues can be overcome this way. So now that we have learned like what is Docker, like what is containerization, let's go into more depth by studying different Docker objects. Good to proceed. Any questions? Okay. So if you see here, yeah, this is the container we were talking about. Till now, we were just talking about create a container, share the container throughout the same container can be used. But strictly speaking, containers will not be shared, rather images will be shared. What is that? Let's see. What is this? Docker image. See, your container will be created from a Docker image. Means till now we were talking about container. How are we creating, like how do you get this container? From a Docker image. Means you run the Docker image, you will get a container. Docker image is nothing but the base of a container, right? You have to run that image to get this container. I can say this Docker image is a static file, right? Docker image is a static file or read-only file, by running which you'll get a container. Means container is a running instance of this image, right? Or else a running version of this image. Yeah. And also like we were talking about, create a container, share the container across. Actually, we don't share the containers. To understand the concept, we discuss that way, but we don't share the containers. Rather, we share this Docker images. Developers will create this Docker image. They'll share this image. Ops teams or else testers or whoever want this environment, they'll run this image to create a container. Got it, all of you? So this is one point you have to remember. Container is a running instance of the image. You get a container from this Docker image. Docker image is like a static file. So you can imagine a virtual machine. If you have worked with the VMs, you know this very well. Virtual machine is a running instance, right? If you want to share the VM, do you share that VM directly? There'll be a file, right? You might have noticed this. There'll be a VMX file or else .over file or .vmx file, which you will share to the clients or other teams. They'll run this file to start a container. Am I correct? Have you ever noticed this? Yeah. If someone asks you to share the VM, you will share it in this file format, right? They will run this, they'll get a VM. Same is the case here. You can compare this Docker image to the static file, right? Some analogy. So when you run that, you get a container. Okay, fine. They'll run a Docker image, they'll get a container. But how do you create this Docker image? Correct? So there were so
Preeti, can you
many.
please, sorry to interrupt, can you please come back again on the sharing of the Docker image part? Means, is it development team who creates that image and shares it with the DevOps team so that they
Like we
can
discussed
create the
some time
container?
back. Yeah, some time back we discussed like developers will share the container. They will share it as a Docker image, not as a container. That's the only thing.
Yeah,
The
correct. That's
process
what I
again,
wanted to
everything is
clarify.
same.
Okay.
It might be developers or DevOps team, depends on projects, depend on the company and all. But they'll share it in the form of an image, not a container. Like I said, container is a running instance. We can't share the running container,
Correct.
right? So the image will be shared. Okay, fine. But how do we get this Docker image? See, there were already so many Docker images already created, available on something called Docker Hub. What is this Docker Hub? It's a service. Which service it is? It's called registry service. What is meant by registry? Registry is a storage place of Docker images. Means there were so many Docker images already available in this registry called Docker Hub. You can download the images from there and use it. But of course, yeah, they are all official and they are public. Means let's suppose you need a Ubuntu image. Already it's there. Suppose you need a CentOS Docker image. It's already there. Or else you need an image with Tomcat. It is already there. Those you can download and use it. Means you download the image, run it, you get a container. But what if I need a custom image, isn't it? I want to deploy my gaming app. Right, projects like companies, they need to deploy their own application. They want to containerize it. So how do we get our own image? You have to create your own image from another unit called Docker file. From Docker file, you will create your own image. What is Docker file then again? Docker file is a simple text file which will have some Docker instructions. Okay, developers will create this Docker file to pack their application along with the dependencies and build it. What is meant by building, how to do that, we will learn it. Okay, so developers will create the Docker file by writing some Docker instructions which will pack their application along with the dependencies, build it, create a Docker image, share this Docker image with other teams. They will run this Docker image and create the application. Create the container. Create the container means inside the container application is running. So this is the process and this is the flow. Docker file is the fundamental and the basic unit from which Docker image is created. Like I told you, official images were already there. Okay, default images or official, whatever you call it. So many official images were already available on Docker Hub, which is on official registry. From here, you can download and use it. But if you want to create your own custom image to deploy your enterprise application, this is what you will do. Right? And yeah, again here, like I told you, there were so many official images in Docker app. Then how are they prepared? They were also created the same way only from Docker. Any image, whether it is official image or your custom image, every image will be developed through the same process. But here official images means, yes, they were created by officially by Docker and stored in Docker Hub. Anyone can use it. If you want to containerize your own enterprise application, you have to prepare your own Docker file, build it, create an image, share that image. Or else if you want, even you can run that and create your dev environment. Got it, all of you? So this is the formula you have to remember. From Docker file, you'll get an image. From image, you'll get a container. How will be answered in the next couple of classes. So let me now come to this picture. So you have a Docker file. See here, Docker file where they'll pack the project code and all. Create an image. Run it to have a container. Also, this image, if you want, you can also, how do you share it with others? Through registry. Okay, you can even push this image to Docker Hub. Others can download it from there. Of course, you can have private accounts and all. Right? So once they download from Docker Hub, they can create different environments with the same Docker image. Like you may create staging environment, production environment, and so on with the same Docker image. Right? So let's suppose this is your image. Okay, Docker image. You can run the same Docker image any number of times and create the any number of containers. Like I have run it thrice. So C1, C2, C3, 3 containers because I run it twice. Same single Docker image, one Docker image. 3 means 3 replicas, or else you want to scale your application, right? Have you ever heard about scaling your application? Yeah. Let's suppose my application is having huge demand. So many user requests are coming. I have only one container. Will it be enough to handle all the requests? So you may have to increase the number of containers to scale to handle all these new requests, right? So you may have to increase your containers to 10. This is how you can start multiple containers. So this is the different, these are the different terms or terminology you have to understand. Docker file, Docker image, Docker container, Docker hub. I'm repeating, Docker file is the basic or the fundamental unit from which image is created. You build it, you get an image. You run that image, you get a container. You can also store those images on Docker Hub. Docker Hub is a registry storage place of your Docker images. Okay. So, any questions in this diagram?
So basically, the this framework is like a Git and GitHub, just a framework.
Like Git and Git,
like.
Like GitHub, that's all. But this is Docker Hub to store images, Docker images. Okay. So see, yeah, this is what I'm talking about. Just remember this formula. Throughout, you have to memorize this formula. Always, you should have this in your mind. From Docker file, you'll get an image when you build it. When you run that image, you get a container. See, you can imagine container as a container, like a physical container in the transportation world. You'll have containers, right? You'll put everything like all the goods, all the groceries, goods, huge amount of items and just ship the container. Same is the case. You put your application, the dependencies, whatever the application needs, and share this container, ship the container to other teams.
It's like a zip file basically. Once we
You can
unzip it, then we
imagine
can
it
see.
like a zip
Imagine
file,
it.
but
Correct.
this is not zip file. Image is like you may consider zip file a static
Zip
file,
file.
right? Container is a
Yeah, yeah,
running
correct.
instance.
Right.
See, Docker file, like I told you, it's a text file, right? You write some Docker instructions, okay, and create this Docker file. And then it's a set of Docker instructions required to pack the application along with dependencies. See, this is a simple text file. And then you get an image and then a container. So what is a Docker image? What is present in it and all we'll see once we get into the hands-on. Okay, what is inside a container, Docker architecture. We shall proceed to this after installing Docker. Now, let's go to the server. Let us install Docker and let's get started.